Question 16 is an example of a problem-solving question where diagrams can be really useful. We're told that 5 friends are sitting around the table playing the LRC dice game. There are 5 dice, each of which has L, R and C on its surfaces, presumably twice each. The players are seated around the table in a clockwise order in the following way: Alan, Carmen, Ian, Prem and Ruthie. I've represented each of them by the first letter of their name. We're told that each player has 5 coins which are distributed according to which letter they roll on the dice. If they roll an L, that means they have to pass 1 coin to their left. If they roll an R, they have to pass 1 to the right. If they roll a C, that means they have to put 1 coin in the centre, which no one receives. We're given this table, which gives the outcomes of the 5 rolls for each individual player. As you can see, each row adds up to 5. As we know that each player has to pass both to the left and to the right, and each individual player does this in turn, reciprocal connections emerge between each individual player. Here's a helpful way of representing it, with half arrows going in each direction from each player. We can also include arrows representing the centre throws. We can then fill in the details using the values in the table. For example, Alan throws 2 to his left and also 2 to his right. Carmen in turn throws 2 to her left, but only 1 back to Alan. Now that we've filled in the table, we can work on the question being asked, which is at the end of the round, which of the players ends up with the fewest coins? Here our schematic really helps us. We can understand that each individual player only receives coins from their neighbouring colleagues. So A will only receive his 1 coin from R and his 1 coin from C to give him 2 in total, which we can write down. Doing the same for all the other players lets us find out that Alan has the fewest, with 2 coins at the end of the round. This is because he's the only player who only receives 1 and 1 from both of his neighbours. This information is much harder to glean just from the table, so this schematic comes in really useful. If you've figured out that it's only the inputs from the neighbours which determine your ultimate coin value, you can work out the answer a bit more quickly. I've drawn out a section of the diagram to help illustrate this fact. As you can tell, the values circled here could be of any configuration adding up to 5, but that would not change the fact that 2 is the amount received from the 2 neighbours, 1 and 1. It is these 2 numbers which are the only ones that we need to plot out on our schematic. Thus we can see that it's only the left and right values which help us ascertain the number of remaining coins for each player.